All right, 5B notes, focus and directrix. These are unique aspects of parabolic graphs here. So if we have a parabola, the focus is a coordinate that's inside the parabola. It has a distance of p from the vertex, and it lies on the axis of symmetry. Okay, so if we have a parabola, it's going to be graphed on a coordinate plane. Okay, so there's a parabola looks like this. The focus is a point that lies inside of it. Okay, that point is our focus right there. Now the distance from the focus to the vertex, this distance right there is p. Okay, it's the distance between the focus and the vertex. The directrix the directrix is a line that is outside the parabola that has a distance of p from the vertex. Okay, so if we have like a directrix, it's going to be a line outside the parabola, and the distance between the vertex and the directrix is also going to have a distance of p. Now, what's cool about this is that any point that is on the graph is equidistant from the focus and the directrix. Okay, so if we have a point anywhere on this graph, and I know it's probably not totally drawn to scale here, so we have a point on the graph right here. This distance from that point to the focus is the same distance d to the directrix. So the next question is, what's p? Okay. Well, if we have a quadratic equation, okay, vertex form, standard form, doesn't matter. The value of p is 1 over 4a. Okay. So p is 1 over 4a. So if we have a quadratic function, y equals 3 parentheses x plus 4 squared minus 3, okay, our a value is 3. So p, all right, so p is going to be 1 over 4a. So it's going to be 1 over 4 times 3, which is 1/12. Okay, let's sketch this out here. Okay, so going back to our rules. So we have a graph that opens upwards. Now our vertex, remember this is in vertex form here. So our vertex is at -4, -3. All right. So there's our vertex, and we'll graph our parabola. We'll do it in grade. So our vertex is -4, -3. So the focus is going to be up here, right? It's going to be up from -3. So what we're going to do is we will add P to -3 to get the focus. Okay, so the focus is going to be a point right in here. Let's do that in red. Now, the focus is still going to be on our axis of symmetry. So the x value of our focus is still going to be -4. Now the distance, remember the distance, P is the distance between the vertex and the focus. Okay, so we got to add this distance right here, and this distance is 1/12. So that distance right there is 1/12. So we need to add 1/12 to -3. All right, so our focus point, the coordinates of our focus right here are going to be at -4 and -3 plus 1/12. Let me get my calculator out here. Is going to be -2.916 repeating. That's going to be our focus point right there. Our directrix is going to be a horizontal line down here. Now, the directrix is underneath, it's outside of the parabola. Okay, so to get the line at our directrix right there, what we'll do is we'll subtract P from -3 to get the equation of our directrix. Okay, so if we have -3 minus 1/12, it's going to give us the equation of our directrix. This is y is equal to -3.083 repeating. Okay. Again, our p-value is 1/12, so that's the distance between the vertex and the focus and the vertex and the directrix. And so we're going to add or subtract from the y values, add to get the focus, subtract to get the directrix. Now I'm going to show you guys this on an app called GeoGebra. You may have done this in geometry class if you took geometry class in last year. I know some of you did, some of you didn't. So we're going to go here. And so we have our function y equals 3 parentheses x plus 4 squared minus 3. Copy that. So we go to this website, geogebra.org /geometry. Very similar to the Desmos thing. But GeoGebra allows us to do some geometry stuff. We can check the distances as well, which is kind of cool. So we come in here, we'll go to algebra. I'm going to copy my equation just like that. So it's 3 parentheses x plus 4 squared minus 3. So that gives us our parabola right here. Now going back to our thing here, our focus point. Must have cleared my stuff. So our focus point here, we had -4. And what we can do is we can just, whoops, didn't want to do that. So our focus point was -4, comma, And then, we took -3 plus 1/12 there. And there is our focus point. Okay. So -4, comma, -3 plus 1/12. So that gives us our focus point A. Our directrix is going to be a horizontal line. So the directrix is going to be y equals horizontal line. And remember, we're going to subtract P. We're going to subtract P from the y value at our vertex. So our y value is -3 minus 1/12. And so now that gives us our directrix line right down here. Now I'm going to put my vertex point here just so we can have it. So we have -4, comma, -3. There's our vertex B. Now if I go to my geometry tools here, I can do a segment from A to B. And a segment right there, B to C. Whoops. Undo that. I forgot where the undo button is on this thing. We should see the distance from A to B is 0.1. C to B is 0.1. So the distance from A to B is the distance from B to C. Okay, we know that already. Okay. Now what's cool, again, like I said before, is that we could take any point on the graph and it's equidistant to the focus and to the directrix. Okay. So let me just hit my point button right here. I'll just pick some random point on the graph. So I'll hover over here until I get the little hand thing, hit the point D, which is on the graph right there, and I can move it around if I need to. Okay. Now I can draw a line segment from D to A. And then I'll draw a perpendicular line, hit the perpendicular line. So I'm going to hit my directrix in D. And I'm going to make a point where those two meet. Now, again, the rule should tell us that D to A has the same distance as D to E. Well, let's check this out. So we go here to distance or length. DA has a distance of 0.6. DE, hit the distance thing, and then DE. DE has a distance of 0.6. So we see our point D, which is a point on the graph, has the same distance to A, our focus, as it does to our directrix line down there. Okay. Now, if we move D anywhere along the graph, we see that DA is still equal to DE. Okay, move it anywhere along the graph, and we see those distances move with each other accordingly, which I think is kind of cool. So if you want to try it on GeoGebra, you can try it on GeoGebra. I can help you if you need to. If you don't want to try it on GeoGebra, if you just want to sort of take my word for it, that's fine. But here's a little a visual view of what it kind of looks like. Okay. So coming back to our notes, what I want us to do is complete the square. put the quadratics in the vertex form because we got to find the vertex HK, and then find the focus in Directrix. Again, go back to finding our p-value. That's sort of the most important thing. Once we find our p-value, we'll add it or subtract it, to the vertex, to the y-value of the vertex to get our focus, and then um, we'll do the opposite operation, adding or subtracting, to get the line of the directrix. Okay. If you need another example, I can help you out if we need to. Um, Other than that, that should be it. Go back and rewatch the video if you need to, and I'll be here to help you out. Y'all take care.